There you go.
Hi, thank you, David. Hi, everybody. So my name's Donna Seward. I'm the specification manager for Xtratherm insulation, and I cover the East and West Midlands here. I'm here today with my boss, Derek, who stood at the back. You can wave to you. Any questions? Obviously, there'll be plenty of time at the end as well. But if you can't wait and want to interject, that's absolutely fine as well. No problem at all. Just before I go into the presentation, for those of you that aren't familiar with Xtratherm and the product range that we do, I'll quickly run through that. So we've recently launched a brand new product range, end of last year, called Eco 360. And I'll tell you a bit more about that towards the end of the presentation. One of the reasons we brought that out is it's more sustainable. It's made with bio-based polyols. It's halogen-free formulation. It's low in VOCs. It's also got a better lambda value, so a better thermal conductivity of O2O. Normal PIR is around about O22. We do a take-off service to try and reduce down on waste on site. And at some point in the very, very near future, we're actually looking to do a waste collection service as well and actually start recycling the product and putting it back into the production. So looking at that whole life cycle analysis. And that will become apparent a bit later in the presentation as well. So within that range, we do a full fill called Eco 360 Cavity Therm. We do a partial fill, we do a floor product, we do a pitched roof product from between the rafters, under the rafters and on top of the rafters as well. Then we've got Cavity Therm. So Cavity Therm, we were the first PIR manufacturer to launch a full fill PIR insulation for cavities back in 2010. And not long after that, some of the other manufacturers followed. Ours is quite unique. Ours comes with a hip spacer on it, so you can actually fully fill the cavity with it. It maintains the drainage plane. It comes with a variety of different accessories, like preformed corners, internal, external, backing pieces for meter boxes, details for rigid cavity trays, all the areas that normally are very, very difficult to insulate around or just get forgotten about on site. The product itself is also rebated, so it interlocks together. So you truly do get continuity of insulation with this. And one of the plus points of that, particularly as the regs are changing, in the building regs, they're actually looking to provide more photographic evidence of key stages moving forward. So this is only going to sort of help with that process as well. Now with Cavity Therm, because it's a little bit different, it's a bit different to your blown insulation or your mineral wool that brickies love installing, or not installing any at all, which they prefer even more. We do like to go out and do toolbox talks. So pre-start, let me know, either myself or my colleague Craig in the Midlands, who loves doing toolbox talks and getting dirty, goes outside and talks to the brickies. As long as they need him, he's always at the end of the phone if they've got any issues. Then we have SafeR, so that is our phenolic insulation range. That has a lambda of O2O. We're the only one of 2 manufacturers of phenolic insulation in the UK. Our fire performance on that is the best on the market. So we have a Euro classification B for our phenolic insulation boards. And again, it's a variety of different boards for different applications. We then have ThinR Plus, so that's an O21 lambda PIR. We have a suite of PSI values available for thermal bridging for implementing into the SAP as well with that particular range. Already available, ready for energy assessors to use. We have XPS, so extruded polystyrene. Lambda on that is between 034 and 036. It comes in 300, 500 and 700 kPa, so it's got high compressive strength, so particularly for your commercial type buildings where you've got a high weight load. Doesn't ingress any moisture, so inverted roofing systems as well, that kind of thing. EPS, Xtratherm started manufacturing expanded polystyrene back in 1986, and of course back then it was quite adequate to insulate our buildings with polystyrene. I remember when I started in the industry, putting 25 mil polystyrene in the cavities was deemed okay. We've come a long way since then. We do still manufacture it over in our plant in Ireland, but I haven't actually specified it in the 3 years that I've been with Xtratherm. It doesn't quite meet the fabric standards anymore. Lambda on it is 031, so you can see it's not great. Then we have Xtratherm. Again, this is a range of PIR products for different applications. The difference is in that range is it has a Euro classification C for fire, whereas commodity PIR either has an F or we don't even bother declaring it basically. So that's a better fire performance on that. Also has a few other little differences, like the partial fill has a slightly different foil on it, so it has a lower emissivity as well if that product is specified. So again, you might get a slightly better U value in the cavity with that one. Thinner, commodity PIR, 022 lambda, exactly the same as all the other brands out there on the market. We have Stonewall, that is our 035 lambda A1 non-combustible mineral wool. So obviously in England, any buildings over 18 metres have to have non-combustible insulation in the walls. So that's why we don't manufacture it, we actually import it. But we lost quite a lot of, I suppose, opportunities for specification following Grenfell, so that is why we brought that out to plug a gap, really. So we have that as well. We pretty much have something for everything. And then the last one on the list is Xtravip. So that is a vacuum insulated panel. So it has a super duper lambda of 0.007. Also has a super duper price point that comes with it. So it's vacuum insulated. It's quite niche, so it's where you've got threshold issues. You might specify a balcony where you need something really, really thin but still achieve a really good U value. So terraces, some roofing applications. Now the information we'd need for that would be the same as designing a tapered scheme. So we have a PIR tapered scheme called Xtratherm. Xtratherm we can manufacture pre-bonded in the factory up to 410 mil in a single thickness. That's the Xtratherm. The Xtravips, same sort of information we need to do a design. So we'll design the roof area, we'll need a scale roof plan where all the outlets, penetrations, roof lights, all of that is. We'll come back to you with a little jigsaw puzzle telling you where everything needs to be laid and an area weighted U value calculation. So that's the product range. In terms of technical support, we are there to support you in practice. We are there to support you through your education. Xtratherm supports CPD in many ways. We sponsor quite a lot of events. We sponsor the Architectural Technologist Awards as well. And as I say, we are there for you guys. So we can do U-value calculations, obviously. We are covered under the BBA competency scheme for U-value calc. So we get audited on a regular basis. So we make sure that the information we're providing you is absolutely accurate and true. We can also do thermal modelling, so should you have bespoke junction that you need to accurately assess the heat loss through that for condensation risk, or you need to input it into a SAP calc, that type of thing. We can do that. We don't charge if you're specifying our products, basically. That's how it kind of works. And we're also qualified energy assessors as a team. So I'm a qualified energy assessor with Elmhurst. And we use that as a feasibility study. So as an example, if you had a scheme of houses and you weren't sure, because you've got a heating system that doesn't necessarily perform very well in SAP, whether your design will get compliance, we might input that information into design SAP on the worst performing house type and tell you what you need to do, what changes you need to make in order to get it to comply. So that's enough about Xtratherm. So today's presentation is called Designing to Zero Carbon Regulations Future Home Standard, and we're also looking at the RIBA Climate Challenge 2030 as well. So to begin with, I'll give you an overview on the consultation that came back in January. Was it January or December? I can't remember now. Time goes really fast. New Part L, which is being implemented next month, we'll have a look at a specification for that. We'll have a look at some additional areas of focus within the changes that are coming our way as well. We'll touch on why the government decided to keep the Fabric First approach. We'll then have a look at the Future Home Standard. So the government have published an indicative specification, notional specification for that. We'll then take a look at the RIBA Climate Challenge and the role of embodied carbon within that, and where we may or may not be going in terms of future legislation. And we'll compare a couple of different comparisons with those changes as well. So this slide just has a lot of links basically to a lot of the government documents, etc. So if anybody does want a copy of the presentation, just drop me a line. My business cards are out on the table out there. Drop me a line and I can send it out to you as well. So, in January of 21, that's what it was, the government announced the results of the consultation, and we did wait quite a while. Obviously they had quite a lot going on their plate, and finally they decided to let us know what was happening and when it was happening. So they said that improving the energy performance of buildings is vital to achieving net zero emissions by 2050 and protecting the environment for future generations to come. The radical new standards announced today will not only improve energy efficiency of existing homes and other buildings, but will also ensure our homes are fit for the future by reducing emissions by at least 75%. So they'll be highly energy efficient. So come 2025, they're saying that these will be future-proofed with high levels of energy efficiency and low carbon heating, meaning no retrofit will be necessary as the electricity grid decarbonises. 2025, we're not looking at installing any new gas boilers in our new dwellings, so no fossil fuels, LPG, oil. So you'll be looking at low carbon heating systems like your air source heat pumps. And these are going to be zero carbon ready, with 75 to 80% less emissions than ones built to today's Part L 2013. So this is the timetable for implementation that the government have published. So in December, they actually published interim Part L. So that's what they're calling it, interim Part L. It's a stepping stone towards 2025 changes. So now published Part L, Part F and overheating for domestic and non-domestic buildings. 15th of June, so next month now, time does fly, it comes into effect. So developers must submit a building notice, initial notice or deposit plans by June 22 for transitional arrangements to apply. So a couple of changes there. Transitional arrangements, you've got a 12-month grace period, so up until June 2023. The other big change, which probably will catch a lot of people out, I talked to quite a lot of developers and they weren't aware of this, is that it's going to be on a plot-by-plot basis. So rather than being able to build the whole site out to the same version of the building regulations, it's going to be on a plot-by-plot basis. So if you haven't made a meaningful start on half of the plots, say 100 houses, for example, you've made a meaningful start on 50 of them. The transitional period is over, come June 2023. The rest of the plots are going to have to be built to the newer standards. Brilliant, isn't it? Yeah, long overdue, long overdue. Oh, I'm getting ahead of myself there. So that's Part L21. There will then be another consultation in 2023 for the changes that are coming in 2025. As I say, they have already published indicative specification for that, which we will touch on. We actually have a project which just won an award actually at the Construction Excellence Awards last week called Project 80 for Midland Heart, and it was built to the Future Home Standards. So it was built with around about 75 to 80% less emissions over Part L 2013. And it's expected that the occupants of those dwellings are going to have a 65% reduction in their heating bills, which is brilliant, isn't it, considering the state we're in now. I'm more than happy to share the specification they chose to adopt on that. Didn't quite follow the notional specification that the government have published. What they did, rather than having triple glazed, they went for double glazed, but optimised on the fabric, so they went for a 0.3 U value instead of a 0.15 U value. But again, if you want to know more information, the occupants are actually moving in next month. The site's been a little bit delayed for handover, but it's going to be metered, monitored. The occupants are going to have apps. They're going to be taught how to use everything. They're going to be interviewed. It's going to be thermally imaged. Everything's thrown at it, and as I say, this is going back to government for the consultation. So the government has also tackled ventilation. So there is a new requirement for additional ventilation for indoor air quality. Overheating, so new overheating mitigation requirement in the building regulations as well. Transitional arrangements we've already touched on. Non-domestic buildings, they're improved as well, meaning they'll also be zero carbon ready by 2025. And existing homes will be subject to higher standards with significant improvement on the standard for extensions. making homes warmer and reducing bills, and the requirement for replacement, repairs and parts are to be more energy efficient as well. And this includes windows, fixed building services, heat pumps, cooling systems and fixed lighting as well. So originally, in the consultation, the government proposed removing the fabric energy efficiency target, which was bonkers. You guys all know that it's the first port of call to any low energy design and reduces the demand on the heating system as well. Brilliant. So there's a massive backlash from industry, and thankfully they decided to keep it, so it is still a metric within SAP for compliance. So what you have here in table A here is the draft future home standard specification, which the government have published. So for your floors, you're looking at a U value of 0.11. For your external walls, you're looking at a U value of 0.15. Roofs, 0.11. Windows, triple glazed at 0.8. Air permeability is still based on 5, and your heating appliances, of course, that low carbon heating, such as your heat pump, and no PV, because obviously heat pump is classed as a renewable in itself. So some of the details. So Part L, into effect next month, is a 31% reduction in CO2 over Part L 2013. And you've got the following 4 metrics for compliance moving forward. So there's going to be a primary energy target, brand new metric in SAP that energy assessors are going to have to get their head around. Of course, you've got a reduced CO2 emission target, fabric energy efficiency target, and also minimum standards for fabric and fixed building services. So what is primary energy? Primary energy is the energy produced from renewable and non-renewable sources that have not undergone any conversion or transformation process, and it considers how much energy in kilowatt hours is needed to provide heating and hot water to the dwelling. Also looks at lighting, ventilation, cooling systems and showers. CO2 emission rate, we're familiar with that these days, and it's obviously stems from the burning of fossil fuels, which we're trying to move away from. Fabric energy efficiency speaks for itself. Specifically looks at the energy efficiency of the construction and the effects of air tightness, thermal bridging, the U values and thermal mass as well. So they revised the minimum standards as well. So the backstop U values, they've lowered those. So Part L 2013, the backstop U value for cavity is 0.3. So you can see they're now bringing that down to 0.26. So that will affect potentially some of the larger developers out there that unfortunately are still designing cavities to not very good U values. So we are seeing a lot of changes in specifications in terms of that. Obviously, if you followed these as your backstop U values, typically SAP wouldn't comply anyway. They have to be significantly better than this, but it just allows a little bit of flexibility within your designs. So an example of that would be your dormer cheeks. They're still measured and input into SAP as external walls, but obviously you're restricted on space there. So you could design them at 0.26, but have your external walls at 0.18 still. Just allows you a little bit of flexibility. So on this slide, you have the backstop U values that we've just had a look at compared to the notional dwelling specification for Part L21. So you can see they're far lower. So you've got double glazed windows at 1.2. Your U values for the cavity wall is 0.18. Your floor is 0.13. Your roof is 0.11. Your thermal bridging Y value is 0.05. Air tightness is 5. It's always based on 5. Still based on a mains gas boiler for this recipe, and I'll explain why that is a bit later on in the presentation. But you also have the addition of a wastewater heat recovery and PV panels. And the reason for that is because of the gas boiler. So in terms of if your clients don't want to have 40% of ground floor area of PV, for example, they might want to consider putting an air source heat pump in now. It's also kind of future-proofing it, really, when you know that's where we're going anyway. So why a stepping stone? Why not go straight into the future home standard specification if they know where they're kind of going with it? And the reason for that is allowing industry the time it needs to develop supply chains and skills to be necessary to deliver the future home standard and accounting for market factors. So we'll be going away from installing around about 30,000 air source heat pumps to about 600,000 air source heat pumps. So there's a lot of upskilling required and manufacturing And let's face it, it's difficult getting hold of anything, toilet rolls even these days sometimes. So, yeah. So this slide here basically was looks at, obviously originally we were looking to be zero carbon by 2016. The government did produce a specification. They knew the fees and metrics that were required back in 2010. And it didn't happen. They didn't change the building regs, as you know, in 2016. So obviously been long overdue. And this slide here was an article that was in The Guardian, basically looking at even homeowners that are buying new homes that built today, Part L 2013, even Part L 21, as I mentioned, if you're installing a gas boiler at some point, that's going to have to be retrofitted. Homeowners potentially are going to be faced with a bill of around about £20,000 to make their homes greener. So this slide compares the original 2016 specification, which didn't come into effect. Then you've got Part L 2013. Then you've got Part L 21, as they're calling it, which comes into effect next month, and the indicative future home standard specification here. So at a glance, you can see where all the changes are pretty much coming in. So in terms of floor, we're moving away from 0.13 to a 0.11 in 2025. So that's around about a 25mm increment of PIR insulation or phenolic insulation. Where you've got your external wall, we're moving away from a 0.18 this year to a 0.15 in 2025. Again, a 25mm increment. So 0.18 with cavity therm full fill will get you that with a 100mm cavity. For 2025 to achieve 0.15, you're looking at a 125mm cavity. So the cavity widths will either be stepping out, depending on what insulation you're looking to install, or keep them as narrow as possible and use the better performing types of insulation. There's quite a lot of choices out there, and we'll cover that off a little bit later on in the presentation as well. Obviously, you've got your windows triple glazed for 2025, but again, doesn't have to be. You could opt for double glaze, but you're going to have to improve somewhere else in the recipe. Your low carbon heating 2025, your gas boiler for this year, if you install a gas boiler with that 40% of ground floor area, and a wastewater heat recovery system. So changes to SAP. There is a version of SAP out called SAP Beta at the moment, which was based on the response to the consultation and what the government published. They're actually working on the software right now, so hopefully it'll be out any minute. We've been waiting for it to land, and obviously it's leaving it right till the last minute again. But we've been playing about the SAP Beta anyway in order to get compliance and just getting our head around the primary energy aspect of it. So obviously we've still got the fabric energy efficiency. Primary energy rate, that new metric. Another big change is your thermal bridging. So where you've got table K1 and you've got government approved values for the heat loss called PSI Values associated with that, they're removing the government approved values and leaving default figures, which are going to be worse. So what that means is that energy assessors can't just rely on using the accredited construction details to get compliance for your thermal bridging anymore. They're going to have to go out there and put a bit more work in and seek manufacturers' data or independently assess PSI values for those junctions. In terms of what you build on site, it's exactly the same as the details for the accredited construction details. It just means the heat loss has been accurately assessed with those products actually involved rather than generic values, basically. There's also going to be 2 new junctions as well, which are roofing junctions added. So there's 44 in total, which your assessor will identify within your design and implement into the SAP assessment. And if you think of thermal bridging as a penalty on your fabric, so you can have really good U values, but if you've got really poor detailing in terms of the thermal bridging, that is really going to affect your fabric within the assessment. So the better the detailing, the better the overall fabric is going to turn out. You've got your ventilation, so more options added for that. Lighting, more precise details will be required, like the types of lighting, pendants, downlighters, luminums per watt even, so expect a few questions like that coming your way. And more precise details required for water as well. So the lower carbon factors that will also change heating design. So you're probably all aware that currently electricity performs very, very poorly unless it's a air source heat pump in SAP. So SAP hasn't been amended since 2012 to take into account the renewable energy in the grid now, the electricity grid from the renewable sources. So this is the first opportunity they've had to do that. So normally it's around about 2.4 times worse than gas at the moment. So it's going to level that out. So gas, electricity are going to be around about the same. And of course your air source heat pumps are going to be even better still. So as I touched on thermal bridging, the choices available for applying this to your energy assessment is choice option A, is to use construction joint details calculated by a suitably competent person following BR 497. So my guys in the technical office are suitably competent people. So we can thermally model junctions and PSI values for you. We can do bespoke junctions for your project based on your actual designs. Again, that's just something to talk to us about. Option B is to use junction details from a reputable non-government database like the LABC or the BRE. C is to use the default values that are going to be left, but again, it's going to be tricky to get compliance with those alone. You can mix and match from different sources, as long as the energy assessor can prove where he got the data from, that's fine. Or D is to use a Y value of 0.2. So within SAP, there's an option, a tick box called default. And an energy assessor should really only use that if no attention had been paid to the detailing whatsoever. Hadn't got a clue what had been done on site in terms of detailing the thermal bridging. They got audited, so they have to be accurate and honest. So currently the Y value in SAP is 0.15 for default. They're making it worse, 0.2. So as you can see, it's in red. It's a warning. It's just not gonna comply. So it's not an option. So putting more and more emphasis on thermal bridging and getting that detailing correct as well. So this is an example of option A, so suitably competent person. So this is one of Xtratherm's PSI values. So this is based on cavity therm in the cavity with high floor in the floor. You can see at the bottom there's a sign for a PSI value. It looks a little bit like a pitchfork. Our PSI value for that particular junction, E5 junction, is 0.02, so that's really low. Currently in table K1, the approved government value is 0.16, so you can see how much lower ours are. And as I mentioned, it is a penalty on your fabric, so the lower the Y value, the better the fabric is going to perform. And this is an example from the BRE website. This is a lintel junction, again, with cavity therm. All our junctions are on there. We've just redone another suite of PSI values as well, so we've kind of expanded on what we have available. So just to give you an idea of the penalty that poor detailing would give you in terms of the assessment. So if you have a dwelling with average U values of 0.15 through the elements, the roof, wall, the floor, if you chose default in SAP with that Y value of 0.2, that would actually make your average U value 0.35, which is rubbish, isn't it? Considering the notional specification this time round is 0.18, you can see you're going to be miles away. If you use a Y value of 0.08, which is around about where the currently where the accredited construction details, the approved figures currently sit, the accredited construction details, round about 0.08, which is pretty average, that would make your average U value 0.23. Better, there's a good chance you'll get compliance with that, but there's better still. So using our PSI values, for example, which perform really well, on average has a Y value of 0.03, so again making that average U value of 0.15, 0.18. Hey presto, it's that simple. So now let's have a look at Part L, Future Home Standard, RIBA Climate Challenge, just to see what they're up to. NZEB and Passive House, so, you know, what do we aim for? So RIBA themselves, 2 days after the government passed a law to end its contribution to global warming by 2050, declared their own climate emergency. They don't believe government are acting fast enough to tackle climate change. And we all know, you hear it in the news every day, you know, how much the polar ice caps are melting, temperatures are rising, we're not on target to meet that 1.5 increase and all of this. So they're saying that we must act now and ensure that new and retrofit buildings deliver net zero whole life carbon in advance of any future regulation. And they're also considering making it a mandatory competence for RIBA chartered architects. So what you have here is a snippet from the RIBA Climate Challenge. This is based on a domestic dwelling. And what they're looking at is three things really. So operational energy, it's a reduction in operational energy. So business as usual, you're looking at 120 kilowatt hours per metre square per year. They're challenging architects to get that below 35. Embodied carbon, now that's not a metric currently, but at some point in the future it's very, very likely to be. We have a separate CPD based on achieving the embodied carbon targets within the RIBA and LETI climate challenges, and quite a lot of data on this as well. So again, if anybody wanted to learn more about that, then get in touch. So in terms of embodied carbon, 1,200 kilograms of CO2 of energy per metre square would be business as usual, and they're challenging RIBA chartered architects to get that below 625 for all the different dwelling types. Potable water, so the reduction from 125 litres per day to 75 also. So obviously when you do a SAP calc, when you're looking at operational energy, it's only going to give you a guesstimate based on the amount of bedrooms, the amount of showers, etc. that you've got. Until that dwelling is lived in, and everybody uses their homes very differently, you're never going to know what the operational energy is going to be. So in the absence of having confirmed metering systems in place, which obviously you're only going to get the information post-occupancy, they're actually saying that heating demand should be less than 15 kilowatt hours per metre square per year, which is similar to that of passive levels. So, embodied carbon and regulations in the future. The Environmental Audit Committee have already said that the government should include targets for embodied carbon. The government themselves have actually launched an inquiry into looking at the effects of embodied carbon with the materials that we use to build our buildings. They have actually done that now. And as I say, there's various organisations like the Construction Industry Council as well, also looking at this, as well as LETI. So what is embodied carbon? Embodied carbon emissions are generated from the processes associated with sourcing the materials, fabricating them into products and systems, transporting them to site and assembling them into a building. They also include the emissions due to maintenance, repair, replacement, as well as final demolition and disposal. And that 51% of that pie chart you see before you is actually carbon emissions to practical completion. So that's even before it's operational. So it's an awful lot of embodied carbon at some point is going to have to be addressed. So we as manufacturers need to produce environmental product declarations with carbon scores to allow life cycle analysis calculations to be done. So all of these EPDs should be based on the factory that the product is actually supplied from. They have a 5-year lifespan, so every 5 years we have to update them. And these are key to calculating the embodied carbon targets within these challenges. There are generic carbon scores available, but of course they're going to be high and they're not going to be accurate. So certainly industry is getting there. People are catching up. As I say, we kind of like to be in the forefront really of before anything's legislated for, and be prepared and learn everything there is to know about it really. So we modelled a semi-detached house under Part L21, Future Homes and the RIBA Climate Challenge, and they can all be met very, very similarly. So obviously your operational energy use for the RIBA Climate Challenge, you'd be looking below that 15 kilowatt hours for that. Floors 0.14, walls 0.18, roof 0.10, windows 1.4, gas boiler for Part L21 and heat pumps for 2025, and also the RIBA Climate Challenge. And then obviously you've got that 2.2 kilowatt of PV with the gas boiler. So, insulations to meet 0.18 in traditional masonry. So obviously you don't want to be extending your cavities beyond 150mm for structural reasons. Other reasons would be gross internal floor space. Obviously that has a monetary value. Can also mean the amount of plots you'll get on a piece of land. You know, you could get extra plots on if you keep your cavities as narrow as possible. So what we've done is we've based these examples that we're showing you on a 150mm cavity as a maximum. You've got your different types of blocks across the top, so your lightweight, medium, dense blocks. And you've got your different types of insulants down the side there. So you've got a phenolic partial fill 018 lambda. That's fine within a 150mm cavity as a partial fill. The same as partial fill 022 lambda within a 150mm cavity. Partial fill, PIR full fill 021 lambda, so that would be our normal cavity therm, not our Eco 360 cavity therm, because that performs slightly better. But within a 150mm cavity, we actually achieve 0.13, so allowing you then to reduce that cavity down to 100mm to achieve 0.18. And not only do you get the benefits that I've already mentioned, but also if you're calculating embodied carbon, the less material, the thinner the materials, the less embodied carbon. It's like your triple glazed windows, as opposed to double glazed windows. You've got an extra pane of glass, that's obviously going to have more embodied carbon in it. So these are all things to consider when you're looking at these things. Full fill fibre, so your 032 mineral walls like your dry therms, your resivers, all of those, they're really going to struggle unless you're using lightweight blocks in a 150mm cavity. So the choices are getting less and less. You know, there's a greater need for higher performing insulants. Pumped insulation, that's going to struggle, and the same as pumped bead as well. And then you've got an example there for timber frame. So that's 430mm wide wall overall in this particular scenario. So it's a pretty chunky wall there. We've also done comparisons looking at embodied carbon, if anyone's interested, with the different dwelling types, comparing it with traditional masonry construction and that of timber frame, because everyone thinks timber frame is the most sustainable way. It is, but percentage-wise, it's very, very small. When you're using the right materials for traditional masonry, they're actually very close. And the RIBA Climate Challenge can be achieved with traditional masonry. So again, we've got all that data if anybody wants to look at it. I heard that FCIAT are also looking at their own challenge. I haven't seen anything yet, but I've been informed that you may have something coming your way, hopefully. That'd be nice. And then this is an example of a 0.18 U value with a building over 18 metres, so a non-combustible solution in a rain screen application. Again, 400mm wide in this scenario. You have got an awful lot of insulation there. Obviously, mineral wool doesn't perform as well as your PIRs and your phenolics. The wider the wall, the more bracketry, the more penetrations you're going to get through the insulation layer, which should be calculated in the U value. Also, the more insulation, the worse the PSI value is for the floor to wall junction as well, which will obviously be taken into consideration in any energy assessment. I'm not going to read this because I read it in the beginning, but that's just an overview of what we have just covered. And that's it. Has anybody got any questions? Hello, Steve. Could rely on you.
I was always going to have a question.
Yeah.
I've got a couple of points. Well, thank you for an excellent presentation. I mean, I was enthralled with the updating information. That was really super. And it brought me to start thinking about some of the services you've already provided. So all the calculations you can do. And that's not new, that's been going on for years.
Yeah.
But what would be interesting is to know whether you are going to extend that and put it into some form that Dynamo or one of the other graphical programming interfaces can pick up on, so that we can drag the information in quickly, because there's an amount of information we now have to think about.
Yeah.
Is there something that you can give us that allows us to pick up that information on a database that we can pick up through Dynamo and pick it and use the calculation? And there lies the second question: is there a way that you can start to help us understand all of this by putting in a drag-on block that allows us to put the wires in and pick up the information from the model we've already drawn using your knowledge base that you've already got? That would be seriously very interesting.
Okay, well, it's not a question that I can actually answer right now.
I didn't expect an answer, but I'm asking.
Yeah, but yeah, I will ask Danny, who you know very well, who's our technical director. You know, we are always sort of forward thinking and doing what we can and sort of staying ahead of the game kind of thing. So if you wouldn't mind dropping me an email, and I can send it on to Danny and I'll get a response for you from there.
Yeah, thank you very much.
Thanks.
Thank you.
Okay.
Excellent.
Anybody else? Yes.
Could I just ask about the table K1, thermal bridging table? Is that something which we can access to? Are there standard details which we should be following, and would the sub-assessor be expecting us to produce those sort of details at each new assessment?
Yes. So normally you'd advise your sub-assessor what detailing you were using. So typically in a specification you'll see under thermal bridging credit construction details. But as I say now, you probably wouldn't want to be putting that on your specification. So if you are specifying Xtratherm, you just put under thermal bridging, go talk to Donna at Xtratherm, or refer to the website because all the details are on there as well. So yeah, just make those points just to help them out because it's, as I say, it's a big change for them as well.
Great.
Okay. Anybody else? No? Okay, well thanks everybody. Thank you.
I think we've finished a little bit early for the next presentation. We've got time for people to have a chat. Got some hot food coming. No caviar, champagne, unfortunately, but we've got pizza, so that should go down okay. So I think pizza's coming probably in about 10 minutes, and then David, what time are you?
Whatever you want me to, mate.
Yeah, maybe about sort of 6:15. Is that, if that's okay? We'll get going with the BIM presentation. So yeah, if everybody wants to go back into the foyer, bit of networking, bit of a chat, and some food. There's tea and coffee out there as well. Thank you. That's also out there, and I'll leave you with David and his robotic dog.
Right, good evening. There you go. Yes, we're recording. We just had pizza, so everybody's like that now. Not ready for a nod off. Right, my name's David Heesom. I am the programme leader for the Architectural Technology course here at Wolverhampton. I'm also a reader. In BIM, reader is a term that nobody outside of academia understands what it means. Essentially, it means that I'm an academic, but a lot of my work is R&D. It's research and development. I spend quite a lot of my time, or I did do before COVID, spent a lot of my time out doing sort of applied R&D projects with companies, predominantly around BIM implementation, technology implementation, things like that. So Paul asked me if I'd do sort of a bit of a talk. I said, what do you want? They said, BIM basics. I said, basics? He went, yeah. What kind of basics? He went, like, right down. Like down here, start from scratch. I said, okay, we can start from scratch. But then we kind of want to do some techie stuff as well, because we want to see where things are going, because we've got a lot of kit, as you can see, and we're doing a lot of R&D and research stuff as well. So we'll start down there, which for some people might be a bit, close your eyes and think of sunny holiday time. All right, and then we'll get on to the interesting stuff after that. I thought before we started though, I'd be interested to tell you a little bit about this, because I suspect there's quite a lot of people who've never been to this building before, never been to this facility before. It's a new facility. There are a few people who are. There's some alumni in the room as well who are probably going, why the hell didn't we study here? We were stuck in the old building in the city campus. This is the new School of Architecture and Built Environment at the University of Wolverhampton. For those of you who don't know anything about Wolverhampton, it dates back to about 1850 as an institute. Some of it's still standing. It's gone through lots of different transitions. 1930s, we turned into the Technical College. 1957, not a lot of people know this, but we were actually one of the first universities to be given a computer called Which. And I can never remember what Which stands for, but we were given one of the first learning computers in the School of Art. 69, we became Poly. 92, we became post-92 university. And in 2014, the university bought this site, the Springfield site. For anybody who knows Wolverhampton at all, this is the site of the old Springfield Brewery. It's about 12-acre site that we've got. So we own everything from sort of the boundary over that side, which is Block A, right the way down to the Cannock Road, right the way up to the boundary line on the canal. One of the most blighted, sort of horrible sites in the city. We bought it and we decided we'd regenerate it and turn it into the School of Architecture and Built Environment. Everything on this site that we build will be built environment focused. So this is the flagship, the new school. We have a high school that we sponsor across the way. That's all construction focused. The elite manufacturing centre over there. We are just about to open the National Brownfield Institute across the way, that horrible grey looking thing as you come in. Don't get me started on that one. That building over there, right next to this, like Beauty and the Beast. But that's a sort of central government funded initiative all around brownfield regeneration and bringing R&D for that. So the brewery, just to give you a little bit of background, because it's quite an interesting building. Hopefully you'd like to see it. At the peak, it was creating 1,500 barrels of beer a week, employed around 900 people on the site. It was originally built in 1873 by William Butler, who originally had his brewery in Priestfield, the side of the city, and then we dug the clay out from there to start building this brewery. Clock Tower was built in 1922. It was dilapidated until we took it over. We've now reinstated the clock tower. We put that back. In 60, it was taken over by Mitchell and Butler, so it became an M&B brewery. They stopped making beer in 91. The site was then bought by developers. There was 2 fires in 2004-2005. The first fire didn't do the job, so the second fire was obviously lit to try and finish it off so they could get all the planning for it. And then in 2008, they just walked off site and left it. And it was literally left. When we took it in 2014, everything was just left on the tables. They just walked out, closed the gates and walked out and left it when the crash happened. So we bought it in 2014. We set about regenerating it, building this building, designed by Associated Architects. This is the second design, with the first one done by Atkins. That didn't go to plan. So we had another design done by AA. Started building it, started demolition works on some of the old parts in 2018. Built it through 2019 and through the pandemic. ISG were the main contractors. They took one day out just to repurpose the site for social distancing, and we took handover of it on, I think it was the 28th of August 2020. We did about 3 weeks teaching in it, and then we got locked down again. So this is the first year that we've actually used the building. So that's a bit about this building, this facility that we've got. Amazing facility. What we want everybody to do is know that this exists in Wolverhampton, because it's like the best kept secret in the world. Everybody walks in, I didn't realise this was in Wolverhampton. Yeah, it is. It's one of the best facilities in the country that we've got. So anyway, back to what Paul asked me to do in the first bit. And you're going to do a bit as well, because it wouldn't be a lecture without getting you to do something. So get your phones out for me and scan that QR code, because I'm just interested to see where people are at with this. So first question, I guess, is your understanding. And I was going to put one at the end and put with it. We'll see what results are. They're yours. We'll put it on paper and make an aeroplane and chuck it down to me. Oh no, he's set it off now. I don't know what site you were finding there. Right, got that one? Next question. Scan that one. Last one, I promise. I won't ask you any more questions. and that one. Because I'm just kind of interested to know where people are at and what your understandings are. So, let's look at some of these. So where we're at, your understanding, yeah, 27, get some of the basics but still confused by aspects of it. Aren't we all? I guess is the main thing for that. Just about using some software, can't see its relevance, so don't worry about it. Kind of what I would expect from some of those. In the office, let's take a look. That's interesting. So predominantly AutoCAD, a lot of Autodesk, Revit, ArchiCAD, not some of the other known ones. What's the others? Just shout out some of the others. Any ideas? Drawing Express. It's awful. Yeah. Okay. MicroStation. SketchUp. Yeah. Any others? Drawing Express is a cool one. That's a good one.
It's like old-fashioned kind of drawing board. So you've got a huge big tablet.
Right.
And then
Nice. That's antique. Safe. And we got process 45, holistic process, using 3D models. I guess the answer to that was actually it's a bit of all of them. So it's actually all of those in reality. Anyway, let's try and unpack some of that a little bit more. So let's start with some basics. How are we going to do this? I'll talk about some basic things. And we'll go back and I'll talk, and I'm not going to, let's say this straight away. We're not going to cover all of this in the next 3 hours. We're not going to cover all this in the next sort of 30 minutes or so, it's whatever it's going to be. It's impossible. It's vast. The topic is vast. The subject is vast. And there's still a lot of answers that we don't know. So that's just how it is. So what we really want to do is go through some bits, at least open eyes a little bit, and trigger some things that might mean you go away tonight and Google something when there's nothing on telly and look it up. Or it might trigger some questions. We're going to do that first and some basics. Then we'll look at some of the technologies that we're using. So some of the kit that we've got here and some of the things that we're doing with it. And we've got some of this, and Nigel's got some of his cool VR stuff, and there's some of the other things. Just to give you an idea of what the kind of technologies are out there, how they're fitting into the BIM in inverted commas workflows. So, we'll start with this one, because that's where we come from. What is it? It's almost become a slightly toxic phrase, BIM, since whenever it was, 2010. But essentially it meant making digital data earlier, producing it earlier, cut down on the cost changes. Our problem, I mean that as an industry, is we aren't that. Right, and I say that from being in the industry as well. Like, we haven't got time to do things better because we're too busy doing the stuff that we do. And that's happened. That happened from 2010, even to today now, still. We're still in that mindset, I think, some of us. And when I say us, I mean us, globally us. So there is a process. One of those things that is a process. It is a process. But it is a process that's underpinned by digital technology. So sometimes you go, like the phrase, can you just do BIM on this? Do BIM. As if it's like, just do something with it. And that's not the right mindset for it. It's a way of working for us. It's a process. Yes, it's underpinned by 3D data. That in itself is a massive change for us. Right? Anybody who was around in the 90s, when we started really using AutoCAD, we went from tracers, when we had tracers in the office, and then we went to AutoCAD. Actually, that wasn't a massive step change for us. I was at Atkins at the time. Because we were doing the same thing, we were just doing it with a different, we've got a mouse or a puck instead of a pen. We're doing the same thing. This came along, and all of a sudden we were doing something totally different, and it freaked us out with it. And that's why I think we've had the challenges with it. It's a process. Read the whole thing in 2016. Yeah, read all the marketing stuff. We achieved it. We didn't get anywhere near it. The malt farmer come along and said, you're still not using digital technologies and you're still not doing it properly. And he reiterated that. Mark is a visiting professor, an honorary doctor at this university now, and he still reiterated that in his acceptance speech last year when he had it. Still saying, you're not doing it, you're not using the technology that you've got properly. And it comes back to that thing of, is it model, is it modelling, is it management, is it modelling and management? What is it? So I think we're still a bit confused by it. And you get to some of the definitions, and they blow your head off. So, for me, this is how I explain it to some of my guys at the start, is you've got a thing, an asset, it's your building. It doesn't have to be a building, it could be a bridge, nuclear power plant, HS2, whatever it is. We've got some information about that we've always had. We've always had files and information, we're just digitising that information. And we've got a model, we've got the 3D model from it. Put all those together, and you've got a building information model. That's all it is. It's nothing, we're not creating anything new, we're just doing it in a different way. Right? So that's all we've got. The process, modelling, is the process of doing it. How do we do it? We're British, we like standards. We like rules, standards of how to do things. That's what we do. Right? So we've got all the standards with it. You get all those other different definitions of it, and functional and physical characteristics and all that sort of stuff. Just don't understand it. Distill it back to what it is. For us, as ATs, we're going to create the models. It's going to be 3D models, they're going to be useful, they're going to have data rich, they're going to have information in them. That's what we're having. Right, whether that's an ArchiCAD model, a Revit model. It could even be an AutoCAD drawing. As long as you think of an AutoCAD block, where you put information on the block, like a W block, that's an intelligent object. It's got data attached to it. Not 3D, but it's got data attached to it. So about digital data for a minute. Some statistics here, right? And I don't know whether you knew some of this about digital data. 90% of the data in the world has been created in the last 2 years. That's ridiculous. Right? We are consuming data at such a rate. We're doing it now. In 2020, maybe the pandemic had some part in this, but people created 1.7 mega data every second around the world. That's how much data we were creating. And we now generate 2.5 quintillion bytes of data every day. Anybody know what quintillion is? I had to look it up as well. It's a byte to the power of 18. Or something like a kilobyte to the power of 18. That's how much we're creating. And we're creating 463 exabytes each day as of 3 years' time. That's just, I can't even comprehend how much data we're producing. And we're doing that as well. We're part of that because we're producing that digital data as well now. That's what we do. As an industry, that's what we do. We tell sort of students and people coming into this industry now, you are not coming into a muddy boots industry now, you're coming into a high-tech industry. That's what we are. With the stuff that we're using, we're a high-tech industry. That's what we're a part of. Zettabytes in the cloud, that's important for us, because where do we put stuff? We store our BIM data, we store it arguably in the cloud somewhere. So we're working on the cloud stuff. And we're sending more and more emails, and slightly less than 500 million now Donald Trump's gone off Twitter, but he may come back again, in which case they will rise again. So just that bit about digital data, because that's important. This tweet came out yesterday, and it just caught my eye. And there's this account said, if you're still referring to BIM level 2, it's like calling a digital radio wireless. And I thought, well, I still call it a wireless. Like, my daughter sort of asked me what I mean when I say a wireless. Because you probably heard that there was a whole BIM level 2. Everybody was talking about BIM level 2 this, BIM level 2 that. Some people are still talking about it. I've refrained from putting the wedge diagram in that everybody puts in every presentation, which was BIM level 2, because we've moved on and we now talk about the UK BIM framework. the essence is the same. The essence of what we're talking about is the same. And what we're really talking about is having digital data that exists for the life cycle of a building, from the very start right through to demolition. We're talking to some of our researchers about demolition information model. We're talking about having that intelligent digital data all the way through the life cycle from it. The concept is the same under the sort of UK BIM framework of BIM Level 2. So what does that mean? What was Level 2 and what is the framework? Well, we created standards. To govern, the building information model is a thing. It's your digital thing. Part of those 2.5 quintillion bytes of data, it's a 3D model, intelligent model. Building information modelling is a process. It's how we use that digital data through design, through all the stages of the plan of work, through design all the way. That's how we do it. How do we manage that? How do we control it? We created standards. And in 2010 onwards, we created the PAS 1192 standards, which were built on BS 1192. We've had for years. So we built PAS 1192 standards. And then it got international, so we ditched them. And from sort of 2018, we had international standards, the ISOs. So all the BIM process now, the use of that digital data, how it works, how we're supposed to work with it, how we're supposed to implement it, is all governed by these standards, ISO 19650. There's different parts. The ones that we would be interested in, arguably, are sort of part 1 and 2, part 4, and part 5. And the reason we're interested in part 5 is because that's all about security. Because we're creating digital data, that digital data can be hacked very easily. And so we need to have that secure data. Right. So we now have all these standards. We now have what was PAS 1192 Part 2, which told us how we should use BIM, how we should use digital tools, how we should approach it, how we should manage that process. That was superseded by the international standards. Good news, the international standards are pretty much written on the BS 1192 stuff. So there are projects out there still using PAS 1192, some have it transitioned. The number of people, the BIM coordinators who I speak to, who get frustrated because documents have been written and all they've done in Word is done a find and replace. They've just found anything that says PAS 1192 and replaced it with ISO 92. They all slightly different, subtle differences. But essentially what that said on, let's go to here, what I was saying was, as you got further down the design, the construction process, so your digital model got more refined, more detailed, so the information that was produced and attached to those objects got more detailed, and then eventually that data got handed over. That's no different to what we used to do. You think of any project I worked on, we started off with the sort of schematics. You started off with 1 or 2 blue files in the hangars, and as the project went on, those blue files got more and more, and the drawings got more and more, and the details got bigger and bigger. It's no different to what we were doing. It's the same stuff. It's just that it's digital data. So we also had these, what we call information exchange points. So that's the point where we exchange the digital data with the client or the appointing party, as it's now called in ISO 19650. So it went from, it's almost like watching the Star Wars films. You know when you watch the Star Wars? I'm a geek, right? So I'm obsessed with Star Wars. So watch the Star Wars films and you see the spaceships evolve. It's the same thing with that. We started off with that wedge and we come down to this one. It's like an evolution of it. Same thing, saying the same thing, it's just evolved. What that's really saying is, at the different stages, and it's made generic because it's ISO, so it's not specifically linked to, say, the RIBA plan, but it is for us. As the stages go up, move on, your project information model, the BIM, the Revit model, the AutoCAD model, whatever you want to call it, gets more refined. Details get more developed in it. The data gets more developed until we go up to construction, and then the contractor starts to use it as well. That's what we're talking about. And this, I won't go through that. There's some terminology that we need to know, and know it's there. This all started, right, all this BIM stuff started. And what, yeah, because we were inefficient, because we weren't using digital technology. If you dial it right back, where it kind of came from was, it was all about asset management. Why the government were interested in it? Because they didn't know what they've got. They had no idea. Assets. So they needed a way to digitise and get digital information on the assets. How do you do that? Best way to do it is from the very get-go, from the start. So that comes to us. It's designed to illustrate. So when we talk about things like organisational information requirements, asset information requirements, that's what the client wants. Our estates team, from our point of view, from the university, our estates team want a set of digital data that they can use to manage these buildings. We've got a massive estate. And the drawings, I've got anyone here from our estates department? No, not this like this is going to be a video. The drawings have got wrong about this estate. Wrong. Everything's wrong. There's windows that there shouldn't be, there's doors that there shouldn't be, there's things that have been changed through the buildings. Nobody knows. So we haven't got a good set of data about our assets. So if we could then specify what we wanted, if I go to our estates team and say, what do you want to manage your buildings? We want this, this and this. Right. We'll then go to our designers and the construction and say, this is what we want us to provide. So that we've got that data so we can manage it. That's simple. Rocket science, any of this stuff. So that's what we talk about when we talk about an asset information requirement. That's what the client, the appointed party, the client will want to manage that building. That then feeds into, we call it project information requirement and exchange information requirements, i.e. every stage of the design, the construction, what information do we want to share? What information does the client need to make decisions at those points? That's what we're asking for. And what data do we want? Do we want them to share certain models, certain details? What do we want from them? That's what we're talking about, exchange information requirements. So we just need to know what that is. And then all that at the end of it, it's this thing where we was talking about handing over two things. So you hand over the building, and you hand over a digital representation of the building. So we've got two things to work with. As a client now, I've got two representations of that facility. Right. One physically I can manage, the other one digitally I can manage. That is the sort of process in 19650. From our point of view, because we create the models, right, we're the ones who are modelling. And so there's stuff in there that kind of bites us a lot. And one of them is, there's loads of acronyms in BIM as well. So one of them is LOD, LODT, LOI, LOIN, or LOIN now. Right? They mean the same thing essentially. The other one's classification. Level of detail, LOD, level of detail, level of graphical detail. What does it geometrically look like? What does that thing that you've created in Revit geometrically look like? Theoretically, in that diagram that went like that, it said that as you went through the stages, that model got more and more detailed. So it started off as a box, then it got more detailed and it got refined. Actually not always the case. I had that conversation with some guys from Twyford's actually. They said, well, we want our bogs and sinks to be really high resolution at the concept stage because we want to sell them. We want the visuals to look nice. Yeah, interesting. So level of detail is what geometrically it looks like. Level of information is how much information is attached to it. Your Revit model, how much data is attached to it. All those together in the old system were level of development. We now talk about level of information need, which we need another standard. So let's have another standard. So we've got another standard, which is BS 17412, which is a standard now for level of information need. And that breaks it down even further into these: geometrical information, alphanumeric information, and documentation. Right, and not a lot of people are picking up on that standard at the moment. That's kind of just floating out there a little bit. The other one is everything that we create. When we create a BIM, when we create that model, we essentially create a database. And so as a database, we need to have what we call keys in a database. So it needs to have something as an identifier. But we use Uniclass, which has been around since the 90s. But now we've got a way to use it properly. We use Uniclass 2015. So that's an alphanumeric code. So everything in that model and everything that's there can be given a unique alphanumeric code. And you can search for it. That's what Uniclass is there for. We store everything in the cloud, which we call a common data environment, which could be Dropbox, how you structure it. But people are making a lot of money out of common data environments. Viewpoint, for example. Autodesk, BIM 360, they're making money out of it. Rebadge a cloud, call it common data environment, happy days, somebody will pay for it. The reality is, we tell the students, use Google Drive. You can set Google Drive up to be a common data environment if you wanted to. That's all it is. So we've got a standard for that. How we structure it. And what that means we can do is, if everybody got their 3D models, we can federate them. There's another word that's appeared now. We're going to have to federate them. Bring them together. Federate them. We used to have the light table in the office where we used to put drawings on the light table and overlay them, and then you can see how they all sit together. That's 21st century of that. Import your models, overlay them on top of each other, see where anything clashes. Then we've got project information model. Bring it all together. Then we need more dimensions. So we've got 1, 2, and 3 dimensions. We need 4 dimensions. Fourth dimension is time, so we can run a simulation of it. That comes from Einstein, really. Everything has to exist with length, width, breadth, and time. Then we need 5 dimensions, so we need to put cost in as well, so we can simulate the cost through a project. First time that was mentioned was a guy called Will O'Brien in 2000. He published a research paper at Penn State University. Published a research paper and talked about 5D. And having met Will at a conference once, he only did it because he wanted to get a paper published with something new. And it just took off. And everybody got excited by it. So then somebody came up with 6D. And then somebody came up with 7D. And somebody came up with 8D. And then the guys at Salford University about 15 years ago started talking about ND. So I think we've kind of dialed back a little bit. We've come back to like 6D as to where we are. So 5D is cost, 6D we're talking about life cycle. And trying to understand sort of, well, some of the things we were talking about earlier. Things like carbon usage, energy usage through the life cycle. We can simulate all that now. We have tools to simulate it. We create all this information, where do we go with it? We have this thing called COBE, which is construction operations, building information exchange. Best way to describe that. Got that 3D model with all the data attached to the objects, the graphical objects. Take the graphical objects and chuck them away, and you're left with all the data. Put the data in a structured spreadsheet, and now you've got a line for every object in the building. That's the simplest way to understand it. That's part of some of our requirements. That's probably 6 months of my syllabus in 20 minutes, something like that. It's a top level. But if nothing else, right, just take some of those things and acronyms and the things that you might want to pick up and read up on. So, the more interesting stuff for us now, where we're going with Nines as well. Where we're going with digital data. We can do all this stuff with these BIM things. So what do we do now? What's big things on the horizon? Generative design, GD, next big thing that's going to happen. AI for us as human races is taking off. Artificial intelligence, machine learning, right? It's everywhere. It's all around us. You don't realise it's all around you. That's how Tesco knows to send you coupons for certain foods, because they've got AI engines that are looking at what you buy and the trends of when you buy it and do you buy it this time of the month and all the rest of it. That's AI. So we're harnessing that now in our sector. The reason we're doing it, if you look at that graph, there's a trend in terms of AI, and the biggest uptake on it has been projected in the planning and design stage. That's where we're seeing it start to happen more. So What does it mean? It's a way of exploring different designs. You give constraints to something, to the system, to the program, and you say, generate hundreds of options for me. Like in the bubble diagrams, some of our students. There's some constraints, that's got to be connected to that, that's got to be near that, go. And it can generate thousands in seconds, whereas you'd be sitting there with your sketchbook for days and days and days doing it. So it's a way of optimizing it, and it learns, and it has constraints. Downside, somebody did this one, if they put the Golden Gate Bridge into it, that's what it would have designed, based on the constraints, the material constraints. But we're starting to get these sorts of different designs coming out, things that arguably we wouldn't have done ourselves, but it's thinking for us. Scary as hell, in one respect, because this is beyond our control now. There's whole ethical things. Who's the designer? Who designed it? Who created it? We can only do this stuff because we're using that digital data, because we're doing that BIM workflow. We can only do that with this. We couldn't do it if we weren't doing it. Bottom line. And then you go on to sort of some of the other work that we're doing, which fits into the BIM workflows, digital data capture, right? With these sorts of things, which I don't know if people have seen. I don't know. I'm kind of assuming this. Make a big assumption, maybe. These sorts of pieces of kit, terrestrial laser scans. Does everybody use them or seen them or use the data output from them? You have, yeah, right. They generate vast amounts of data. Incredible pieces of kit, though. Expensive. 50, 60 grand for that piece of kit. Well, that will measure this room, down to a few millimetres in a minute and a half. So some of the examples here, we've done these buildings, we've scanned these buildings, and then we put them into our Revit files and we build the 3D models from them. Somebody asked, where does the dog come into it? Because where we're going now, is we want to put these sorts of things onto his back. Because one of the problems we've got with... Let's just push these so he comes on a minute. Oops. One of the good things with this is it collects a huge amount of data. One of the bad things is we can't get into certain buildings. Structurally unsound. Asbestos. Stick that on him, and he can. He'll just go walking around the building, and he'll capture all that data for us, which means that we can then create our models from it. That's where we're going with it. That's why we invested in one of these. Anybody's from around here, this is a similar project we did with some students. We captured the Dudley Priory, and we got the students to model that using Revit, and then we 3D printed it. Things got more interesting. And they got an iPhone 12 or 13. That's got a scanner in it, LiDAR scanner in it. That will capture 3D data to very, very low resolution. It's like smart price version of this thing. But it will capture it in your pocket. First generation of it, it will capture it. That means that everybody, at some point, when this gets better, it gets more refined, everybody's going to be a surveyor. Right? We get onto these things. Have you seen one of those? It's called SLAM. It's a 3D scanner, but you don't have to stand still with it, you just walk around with it. So SLAM is simultaneous location and mapping. As I walk around with this, it's scanning, it's got cameras in, it builds up a 3D model of everything it sees as I'm walking around with it. Resolution is slightly lower, but I'm walking around, just walk around the site like I would do normally. I'll capture it. Price point, about 40 grand. One of those. Price point for one of them, about 60 grand. Dog. It's not a It will do outdoor if you're very close to sort of building envelope. If you're out in the field, nah, this is no good for you. You can't cope with it. This simultaneous location and mapping means that it brings together photographs and scan data all into one, and it analyses it and it turns it into a 3D model. Paul has already pointed at him. Price point for him was $102,000 for this one, so about $75,000. Say again. So they're expensive bits of kit. They're expensive bits of kit now, right? So were microwaves in the 80s, right? Not now. So these things will all come down, and they'll reach a steady state point. But the value of them, right? Imagine the value. Let me tell you this example. One of the projects I was involved with, I was working for a company that did the nuclear ductwork, stainless steel ductwork, not just the galvanised stuff, stainless steel stuff for the Sellafield. And they were fabricating up cross-section, size of ductwork, cross-sections about 3 metres, 3.5 metres by a couple of metres. And that stuff has to be like millimetre perfect to go in. There's no giving it one of them if it won't fit. It either goes in and the bolt goes through and that's it, or it doesn't work. They're measuring it like that. We've got a guy on scaffold measuring it. So when we talked about this, I said, I can come and help you with that. Let me show you some of this. And then we talked about BIM workflows and digital data and modelling it. And I went to the MD and said, how much are they? I said, 60 grand. He went, just buy one. How come? He says, because that thing, and it was in the factory, so that thing's been in my factory 3 times. It's been rejected off site 3 times. Every time it gets rejected, it costs me 60 grand. So that is a no-brainer. So I've one of them with it. That's the sort of, that's the value against the cost, I guess. The VR and AR side of things, this is where sort of Nigel's expertise comes in, prominently. Virtual reality and all that. The toy, not toy anymore. It was a toy in the 90s, and we all got fed up with it. In the 2000s, we didn't like it because it cost a lot of money, it didn't really do anything. Now, it's cheap, relatively. The outputs are amazing. This is the kind of cycle we've been through, because we've been involved in the VR side for about sort of 20 odd years now. But we've got to the point now where we've built what we call the construction holodeck upstairs. We've seen that, there might be another session coming the holodeck. We've fitted that with not only the VR headsets, which are pretty stock, but we've built in omnidirectional treadmills. Strap in, headset on, go walking around your site. So we've installed 3 for the moment omnidirectional treadmills up there, which means that you can walk around, actually physically walk around the building. Ready Player One. It is Ready Player One. It's the same tech. So we've built that, and now it's becoming a real thing. It's like a real value thing. The AR side, augmented reality side, we've done some work with that. We're working with a company called Unity 3D, the games engine. We've got a bit of a partnership going on with them, and we're using one of their new tools called Visual Live with these Microsoft HoloLens. Put on transparent, see through it. Walk around site. This is the recording through this. This is the NBI building across the way. We're overlaying the BIM directly onto what's being built as we're walking around it, and we're finding the discrepancies between what the model said should have been there and what was actually built there. And we weren't far off now, I think we could say, we were pretty close.
It was mil rather than...
We're talking millimetres out. So that now, in terms of sort of site work, is incredible. So we've got these tools at our disposal, this VR and AR. And then you go on to this one. Steve, you mentioned this earlier, right?
Yeah.
I have a bit of a bugbear with this at the minute. Because like, everybody's talking about digital twin. And one of the issues is everybody's just substitute. They don't find and replace in Word. This is my thing. A lot of people have done find and replace, gone BIM. Oh, we've had BIM 12 years. What should we have now? Digital twin. That's it. And they're all interchangeable terms. They're not. They're different things. Different things. But that's the marketing stuff, right? I remember going to Digital Construction Week before lockdown 2019. And it was just when everybody was starting to talk about digital twins. Now, before we walked in the Excel, I don't know if it was you I was with or somebody else, but I won't remember. You watch this, I bet you everybody's DAP stands. They've scrapped BIM and they've just put digital twin in. Sure enough, as soon as we walk through the door, first one, help us create your digital twin. It's just scamming. That's not a digital twin. Digital twin's an ecosystem. It's a live ecosystem of data that's coming through. We're starting on that that path with this building. We're creating something we call the Construction Living Learning Laboratory, CLQ. The first part of that was to capture this building as it was being built, and then we're going to pepper it with get all the sensors, build it into a live ecosystem so we can see how this building's working properly. Just to give you an idea of where we're at, some of the things we did. We've captured the building at various points. We captured it before it was demolished. So we scanned it, we captured that. We then worked with ISG, the contractors. We captured it at different points during construction as well. So we're building up a complete data set of this whole building. We captured it using scanning. We also used Matterports. I'm sure most people have come across Matterports, and the guys that use all the time now. Matterport. We also captured it with that. We were doing it for one reason. We were capturing that digital data because we wanted it for our students in the future. Our estates team got wind of it and they were interested in it from an asset management point of view. ISG wanted that data and AA wanted that data because they wanted to validate what had been built on site, mapped and matched their model, their 3D model. So they overlaid the two. So we were capturing data. Think back to that digital data stuff. This is how much data we captured by scanning the building as it was being constructed. Right, we're pretty much at a terabyte of data for this building. And we were scanning it, Matterporting it as we went on. We found out that it took us a lot more time to scan things on site because we didn't have this. One of the reasons for having this as well is at night when sites calm down, that can wake up and that can go walking off around the site with the scanner on, capture it all, come back, sit down, look on, pick it up and bother.
Can you put the actual model into that so it knows where it's going?
Yeah. So we can put paths on it, and I'm looking at this man here because he's going to be like probably leading some of the AI stuff around.
Yeah, well, we also Farrow have got something interesting. Farrow are coming out with some interesting package that works with their kind of cloud tech and the spot that enables it to, because it's only semi-autonomous in its raw state, you know what I mean? It's not fully autonomous, but Farrow are building on that. And exactly what you said, it kind of input data about the building, navigates around the building by itself, based on constraints that you give it.
If you freaky in there, sounds on really. So in here, it's got 3D depth cameras, and those depth cameras, that's what we use for that. The depth cameras on it by default are up to about 20 metres on it, something like that. We've bought another unit which will go to 150 metres, so it will sense everything around it within 150 metres, so it can avoid it. So that means that we can tell it to go around the site, and if somebody's left something in the way, it will know to avoid it and go around it. So that's kind of where this is coming in, is to be able to do that data capture on site without us having to be there. And eventually this thing can just walk around. Because it can avoid, I don't know when we're outside to spot it, but if it walks towards you and you're here, it will avoid you. It will walk around you. So the potential to have it on live sites is massive as well. So we captured this building at different points. We've got scan data of it. We use that for validating the BIM, the 3D model, against what was actually built. And that was all captured using the terrestrial scanners. Did it a few times, did it at various points, finally did it in June. Where are we going with it? We talked about 4D, and we can have 4D simulations of the building being built. We're going the other way. We're overlaying all that scan data of the building, and then we're going to peel it back so we can go back through time. So we've got like the DeLorean of scan data. So we can scoop back through this building at any point to stop and say, that's where we're going to. And we've got them down to a couple of meters with this information. That's where we're going to. Right. So that's interesting for us. It means we can put it in VR and AR. That's an ongoing piece of work. We're going to put the sensor data into the models as well, and actually get to a digital twin. And surprisingly, our estates people have got